This video is for anyone who wants a full step-by-step method to find the magnitude and direction of resultant forces. Now, the question that you're looking at, it's got three forces. We have F1 here, which is 135 newtons. We have F2, which is 90 newtons. And we have F3 here, which is 75 newtons. Now, we're going to write these down and the angle, so when we start the calculation, everything can be quite straightforward. So F1, as we've indicated, is our 135 newtons, and the angle between F1 and the horizontal is 60 degrees. So we would write this as F1 equals 135 and at 60 degrees. And we're always going to be measuring the angles from the positive x direction. So this here is our x-axis, or our horizontal axis, and this here is our y-axis, or our vertical axis. Now the other forces, so for F2 is just simply 90 newtons, and it's going downwards. So let me write that properly. So 90 newtons, and it's going downwards. So that's F2, and we're going to see how we analyze such force in a second. And then finally we have F3, which is our 75 newtons. Now for this force, we want to apply this method where we will measure all the angles counterclockwise from this positive x direction right here. So that's a positive x direction there to the right. And when we measure F3, we're going all the way around there. So that's the angle that we want. So if we were to subtract that 45 degrees from 180, then we would see, using that angle, F3 would be 75 newtons, and it's going to be at 135 degrees. So that would represent the angle then for F3. So the method that we use here is to break these forces down into their force components. So what are force components? Because this is a really in-depth video. So force components, so let's say you were to throw a ball. So this here is representing the trajectory of our ball. So it's just following a straight path. And I'm going to draw a dotted line here, which represents the horizontal distance of our ball, and this vertical line which represents the vertical distance of our ball. So if you can imagine for a second that your ball is on this plane, where this point, which I'll indicate in blue, that's where our ball stops. Now it would take two force components to get our ball up and across. So one force component is what will take it across like that. So that refers to as the horizontal force component. And it would take another force component, which is what gets the elevation now, which is our vertical force component. And those are the two things that we're calculating here, the vertical components and the horizontal components. So for the horizontal components, we're going to use this formula that says F for force and cos angle. And the same thing here for vertical. Only difference is we use F, but instead of cos, it's going to be sin, and then theta, which represents the angle. So you want to jot that down, because I'm going to just erase that and utilize the space there, so you can have the diagram to look at whilst we do the calculations. So let's go for F1 components now. Alright, so I'm gonna slow it down so you can really get the full gist of what's happening here. So for F1 components, remember that earlier we wrote down that F1 is that 135 newtons that's going at 60 degrees. And we also have this formula here that says to find the horizontal components, we use force, cos, and then the angle. And that's exactly what we're going to do now. So when I write this here that says F1 and a little x beside it, that's just the horizontal components for F1. And what will happen now is we use the force, cos, angle formula. So we'll just say 135 for the force, and our cos goes there. And the angle between F1 and the horizontal there is 60 degrees. So 135 cos 60 degrees. And what we have here for F1 is 67.5, and our unit is Newton because that's a force. So we're going to do the same thing again for F1, but this time it's F1y, which is for the vertical components, and we talked about what components are. So we'll just do 135 again for the force because it's the same force really, and instead of cos now we say sin, and the angle is 60 degrees. And when we put that in the calculator now, so if you're using a Casio calculator, those are the easier ones, you just write 135 sin 60 and you should get this answer 116, so 116.91, and our unit is Newton. Again, it's a force. So those two are the force components here for F1. So we're going to go to the next force. I'm just going to go to F3 next. So I'm going to clear that little writing for horizontal components to do F3. Okay, so for F3 components, so we're going to apply the same thing, force cos angle and force sin angle. So for our horizontal components, we'll just write that as F3x. So that's just going to be force, which is F3 here is 75 newtons. So 75, and cos our angle, which is 135 degrees. And that gives us a force of negative 53.03 newtons. And we do the same thing but in the vertical direction. So F3y now, which equals our 75 and sin 135 degrees. This gives us a positive 53.03 newtons. Now what you will notice as well is the sign for the vertical component is positive, and that's simply because our force is going upward. So vertical forces going upwards are positive. But look at the horizontal force component here and you notice that it's negative. And that's because horizontal forces going to the left will be negative. So that gives you the correct sign in your working, and that's why I'm showing you this method to do this question. All right, so let's move on to F2 now. So F2 components. So for F2x, so that's the horizontal component, you will notice here that this is just purely a vertical force. So it's 90 newtons and it's going downwards. So it's vertically aligned with the vertical axis. So this angle, if you want to think of it as 90 degrees, then that's fine because it is. But you don't have to use any angles for this one because the horizontal component is just going to be simply 0 newtons. And that's because it's neither going left nor right. So therefore, no horizontal movement. Whereas the vertical bit, so that's F2y, is just going to be negative 90 newtons because why? It's going downwards. So it's going to be negative. So at this point, we have calculated all our force components, but we have not yet found the magnitude and the direction of the resultant. So that's what we're going to do next. So if you need to pause and take a screenshot or write stuff down, do that now because I'm going to clear this bit. Okay, so these are the components then, just in case you need them, and also for you to be able to refer to them as I use them next. So what we got then for F1, F1x, so that's the horizontal, so that was 67.50 newtons, and F1y, that was 116.91 newtons. What we got for F2x was 0, and F2y was negative 90 newtons. And then for F3x, that was negative 53.03 newtons, and F3y gave us 53.03 newtons. So those are the outcome of the forces. So what we're going to do now, we're going to have to calculate the resultant, and then we'll calculate the direction or the angle. So what we normally ask for, or what you're normally asked for, is to sketch this graphically. And I'm going to show you how to do that now. So the first thing that you would need to do is to sum all the horizontal components here. So what we're going to write here is R for resultant, Rx for the horizontal components. And all we're going to do is we're going to add the 67.50 with 0 and with that negative 53.03. So those are the previous answers that we worked out for the force components horizontally. So this would then give us 67.50 plus 0 and minus the 53.03. So what we have, the sum of the horizontal here would be 14.47 newtons. And we're going to go ahead now and do the same thing, but the vertical component here for the resultant. So Ry then is going to be us doing 116 plus that negative 90 and plus that 53.03. So what we have here is 116.91 and plus 53.03 and minus our 90, and this gives us a sum of 79.95 newtons. Okay, so let's now represent this graphically. So I'm going to just scroll up a little bit, get some space for us to finalize this now. So both of these are positive. So what that means is if I'm to sketch this here like that, then when I draw in this force, the force here for the 14.47 along the horizontal axis, it's going to be here to the right. So I'm just sketching this, remember. So this is what you would do. So 14.47 Newton would appear right there to the right, and it's there because it's positive. If it was negative, then it would be to the left. The 79.95 now for the vertical axis would again be above there, so that would be right there, 79.95. And the reason why this is important is because it tells you the direction of the resultant. So we know then that the arrow for our direction should be going, the arrow for our resultant should be going up and to the right like that. So that's our resultant there. And what we want is that value as well as its angle right there. Now, if you can imagine, if I'm to draw a dotted line like that, then I'm pretty sure you'd agree with me that that would form a right angle triangle. And the resultant is what our hypotenuse would turn out to be. So what we would apply here is Pythagoras' theorem to find the resultant, where we do R for resultant equals the square root of our 14.47 squared plus our 79.95 squared. And it doesn't matter if these were all negative, it would be the same outcome. You just bracket them and square that bracket. So you just write them like this effectively. And that's very helpful for some calculators to avoid mistakes. So our final answer here is 81.24 newtons. And then for the angle now is always us using tan inverse. And because we're using this side, which I'll draw an arrow to show you, this side here, that's our opposite side to the angle. And we're also using this side here, which is our adjacent side to the angle. Then it's going to be the opposite, which is the vertical value. So that's 79.95 over horizontal. which is 14.47. And this now will give us the angle, which turns out to be 79.74 degrees right there. And that's representing the resultant and the direction and the angle for our force components. Now, I've done more challenging videos on this topic, so if you'd like to take this a step further, then check out either one of these two videos and you will take it to the next level. So I'll see you there.